What else would you like to tell us about the things that Qualcomm has planned and some of the things you see as really interesting innovations going forward, you know, even beyond the traditional cell work that you guys have been doing so well for so long?
So one of the things that we're excited about right now is we're building digital brains. And we have a model of the neuron, so how do you compute based on what the input to the neuron is and then what comes out of it. And there are spikes that go down and travel between the different neurons, and the neurons add these things up, and then they decide, do they spike, What it turns out is that you can do this fairly computationally efficiently, but it also turns out that it's a lot of a communication problem because the information is stored in the connections between the neurons and the length of those connections and the interconnectiveness between them. And so it's when does a spike arrive from this neuron that's this distance away and this other neuron that's that distance away, such that they arrive at the same time and add up or subtract at the next neuron and so forth. We've modeled that in chips, and we're actually building chips to implement this. The fascinating thing about it is that it works. The team first built a vision system. They built an artificial retina, a camera, and then that, first of all, did certain optical illusions. So I said, okay, well, I get that. I can see how these local properties would create these optical illusions. I can understand that. That doesn't scare me. Then they put another layer behind it and started to recognize, certain features. We've gotten to the point now where we have a little robot that's got a camera on it, and it sits there and it's like a bird. And if you're in its field of view and you move, it turns and looks at you. This is a totally different paradigm because it's not programmed. It's just taught. And so the notion that you'll be able to teach a machine to do things instead of, program it, it's just a different paradigm. And I'm excited by that. I think that the opportunity there is very large. Obviously, there's a lot of things that people do today that they don't, it's repetitive and it's, difficult. And so we have robots for these mechanical tasks. Now we'll have robots for some of these mental tasks that are repetitive and not things that human beings really like to do.